Hello, everyone. One you for joining us here today for the second OpenAlex webinar. Today, it's going to be focused on understanding your university's research. If you missed the first one was a really great overview on OpenAlex, what it is, how it works, coverage, some of the benefits of using it. So go to our website, openalex.org/webinars if you want to check that out. And feel free to do that. Last time we had more questions than we could answer, so we've had a couple people join us today. We've got Jason Portenoy, who is customer engagement and data scientist at OpenAlex. We've got Jason Priam, who's the founder and CEO here on the line as well, and Justin Barrett, who's a software engineer who works on a lot of the data and metadata structure. So please ask your questions as we go, and they're going to help answer them live. Okay, so my name is Kyle Demes, and I'm a consultant who specializes in research evaluation, and I'm working with OpenAlex on the launch of their new graphic user interface, and I'm really excited to be able to show some of that here today. Today's agenda is all about institutional level research. So how to understand what research you're doing at your institution and to use OpenAlex to do that. Quick agenda, we're going to have an overview of OpenAlex and how you can use it in research intelligence. But we're going to keep that pretty light because there is another webinar on that. And then we'll talk specifically around some common use cases of institutional research intelligence for OpenAlex and also the basics, so that even the ones that aren't covered yet, you leave here with a sense of how to do it yourself. And then we'll turn off the recording and go to Q&A. If you haven't heard the term research intelligence before at a really high level, it's just this idea that research activities are happening around the world in institutions, outside of institutions, but you can collect data on those activities and get intelligence from that. So do analyses on that data to inform actions. So maybe this is new policies, new funding programs, or just guiding your research as a researcher. And that's what we mean when we talk about research intelligence. At the institutional level, so when you're talking to a vice president of research, president, executive, this ends up focusing on a few buckets. So this is what I have here on the left: research strategy, reporting and compliance, mainly for funders, but also the public, opportunity matching, so making sure that the right grant gets to the right researcher or the right donor knows about the right researcher, and then grant writing. And on the right here, I have a few of the questions that people ask with research intelligence in these buckets, but just to give you an idea, what research do we do is a really common one. Are we progressing on our open access goals? Which of our researchers work on a specific topic? So these are the types of questions that people are asking in research intelligence. I want to start with the foundational challenge of research intelligence, and that's it's part of the system that in academia you do publications outside of your institution. And that's really important for the quality of peer review and trust in science. And it is really important that that stays outside of institutions. The challenge is that the publishers don't actually have to give back any of the information about the research that they're publishing. So institutions are academic institutions are one of the only organizations in the world that don't even have a simple inventory necessarily of the data of the research that they're doing. So that limits what research intelligence you can do. And that's where OpenAlex comes in. It's a really large-scale database that indexes works. So currently there's 245 million academic works in the database, and metadata about them that we're scraping from this from these entries to be able to get information on who the authors are, what the affiliations are, where they're publishing that type of work, who funded it. And on the left here, just to give you an idea, these are the current counts of how many of each of these entities are currently existing in OpenAlex. But a couple to point your attention to: works 245 million, institutions 107,000, so really a lot. And at the bottom and left here, you'll see there's an API call that I've put that you can at any point go and check to see what the current stats are as it changes. So it's this relational database that allows institutions to do research intelligence and ask, for instance, what are all of the works in OpenAlex associated with my institution? There are other databases. OpenAlex is not the only one that does this. You might be familiar with Web of Science or Dimensions or Scopus. But a few key features of OpenAlex to keep in mind that I want to reiterate: it's big, it's open, and it's easy to use. When I say it's big, I mean it has larger coverage than the others. This is really important, especially in social science and humanities, but also in other fields where things aren't getting indexed in Scopus or Web of Science. So much broader coverage so you get more robust analyses. It's completely open, and that is a major feature. So all of the data that's in OpenAlex is on an unrestricted use license, so you can use it however you want, and that's really unique here. But not just the data that underlies OpenAlex, also all the code that's used to make it a usable database is also all open. And then finally, and also very importantly, it's a nonprofit. So some of these others are for-profit companies, which also changes the level of openness and transparency that can happen. And my favorite, it's easy. It's really easy to use. You can download the entirety of the database. The API limits are extremely generous, more than any I've ever seen. And there's really great documentation online. But over the last 18 months, use has really been restricted to people who have big data skills. And the launch of the user interface is to try and make it more accessible to people who don't necessarily have those skills, but have research intelligence needs. And that's what this webinar series is about. Okay, so that's the intro and overview. Everything that we're going to talk about with research intelligence and OpenAlex comes down to a very simple and elegant model. You have all of the works in OpenAlex, then you apply filters that are your logic layer. So let's say you have some search terms that you want to search. I often search kelp ecology, for instance, because that's my field. But you also want to limit that to years, countries. You can do all of that and build a logic layer or a complex query. And that gives you the subset of results in OpenAlex that you care about. We call that the list. Once you have that, sometimes that's your ending point, but then other times you want intelligence on that subsection of the data set. And that's what we call intelligence, or using the group by feature. The filter and the group by feature are actually very similar in the metadata that's associated with it. You could use filter as a year, or you could use it as a group by to see, for instance, this change over time on the right. But the entirety of all the research intelligence that you'll be doing comes from this really simple, beautiful, elegant model. So I'm going to dive in now onto some specific examples. And the first one people do is, let's just find all the work at my institution. So if you start with OpenAlex, you can see here I've got represented, there's data sets, publications, conference proceedings, there's lots of types of works. And then I'm just adding a filter for just institution and finding and selecting my institution, and then getting all of the results that match that. And that's as simple as it gets there. And I'll show you what that looks like now in the new graphic user interface. And there's a few features I want to point out here as well. So the first thing is that you can see I used McGill University. That's the one blue filter. Basically, I just clicked institution, searched McGill, and clicked the one that I wanted, and that was it. It automatically updated the results. You can see there's 216,000 academic works associated with McGill University. And then you'll see those other filters. There's some popular ones that people use very often: full text search, the author, open access. But if you click all filters, there's dozens, I think 51 different metadata fields you can search in and filter by. But really importantly, and I want to stress this because it's a great feature about OpenAlex, anytime you build one of these queries, you can see up here the URL that you're working in the user interface is updating. So I selected McGill University, and you can see it's added an authorship lineage with McGill University's ID. So you can copy and paste that URL. You can send it to somebody on a phone for them to check. You can send it to your vice president of research for them to see the exact same thing that you're seeing. So this is a really cool feature. You can also, if you build a complex filter that is going to be really important for your reporting purposes, bookmark that URL. So some really cool capabilities there. Just underneath that, you'll see it's also building an API call. Part of the user interface is making sure that it's accessible to people who don't have API and data coding skills, but I know many librarians who are trying to get into that realm, and this is a really great way of doing that. As you build this analysis, it's going to build an API call that does that analysis. So you can see and start playing with APIs, but also you can build the analysis and send it to your data team or someone who maintains the website, and they can just use that in whatever integrations they have. So really awesome features I'm very excited about. Just under that, like I said, is the filters, and that's where you build your logic layer, and then the results. So over on the right, a couple things to point out. At the top, the sort of 3 lines is info. It's what you'd expect, some like information on the team, how to contact us, documentation on the database, that type of thing. And then under that, two more things I want to point out. The first is an export link, and it looks like sort of a download. The nice part about this is it will download automatically up to 100,000 results at a time. So if you're used to Web of Science or Scopus or one of those where there's a very small limit of how many you can download, the limit here is not about protecting the data because it's all open. It's just more a technical capability of once you get above 100,000, it requires a different type of data skill to process that download, but you can still do it other ways. So really awesome. You can export the results there. You can also change what you sort by. The default is citation, so you're seeing the most highly cited work first, but you could do date as well if you wanted to see more recent ones. And that's how you build the logic layers. The next part on that is doing analyses. So maybe you want to know for your institution which of your publications are matching the Sustainable Development Goals. And that's the exact example that I've used here. So I changed the university to shake it up a little bit. I put Université Laval. And you can see that that's all that I have in terms of filters because everything else is blank. But now over on the right, I've used this group by feature and clicked group by and then sustainable development goals. And now it's automatically populated this bar graph that shows you of Université Laval's research works, how many of them are classified for each of the sustainable development goals. For some people, this will be an endpoint. You could just use this URL at the top and send this to the Office of Research or whoever is requesting that information. But you could also export or download this as well. So earlier when you're in the list and you download, it's going to give you each publication and all of their metadata. Here, it's going to give you the buckets that you pick. So each SDG and the total number of publications in that SDG. So that can be helpful if you want to do some further analyses or your own visualization, but it is all in there. And you'll see here that on every single slide, I'm trying to put the API call so that you can see. All I've done is at the bottom, you can see the institutional ID for Université Laval, and then group by Sustainable Development Goal. So you can start building that as well. Everything that you'll do for research intelligence follows this really simple model. And what I love about it is it allows you to showcase all of the different types of research intelligence questions you could have in a very easy to see table. So the example here is on the left, you can see the use case that you might use it for, suggested filters that I think you would probably use to do that analysis, and then what I imagine you might group by. And then you can see on the right, there's additional things to consider, but let's say you want to showcase research outputs as your use case. For filter, you do institution, find your institution, and then group by whatever you're trying to showcase. If you're trying to showcase your open access, group by open access. If you're trying to showcase the journals you're publishing in, use source, use work type, whatever you want to group by there. For understanding your contributions to research or to any topics, again, you'll start with your institution and then group by whatever topic. So this topic could be sustainable development goals or concepts, whatever you're looking for at that point. Identifying collaborators, again, you'll start with your institution and then you'll you'll group by institution. So what that's going to do is show you for your institution's publications, who are the leading institutions co-publishing with you. So really simple to get that information. Then you might want to understand your collaborations with a particular institution. So I put here, when you have the same, let me show you here. When you have the same filter, like institution, you can do and or. So you can do institution A and institution B, and that means that everything it's reduced to will have co-authors from both of those institutions. So that's getting the collaborative work between those two. And then you could group by concepts to know what topics you're working on together, or years to know over time, how's your collaborative effort with this university changing? Is it going up or down? So pretty simple there. And then 3 more use cases to mention. Benchmarking is a really common one. So imagine you start instead of with your institution with a concept you're interested in or a sustainable development goal. Then you can group by country if you want to look at which countries are leading in that. You can group by concept, institution, or you could group by author to benchmark those different levels of entities. Similarly, if you wanted to start with a concept or an SDG, you could find researchers working on that topic by grouping by researcher. Last one here is one that's increasingly important to universities around the world, but it's monitoring your progress towards your own open access goals. And everyone has a different goal here and a different baseline, but essentially you can filter by your institution. And you see, I also put as an example, you could also just limit to your open access publications, or you could group by open access to see the ones that are open access versus not and how that's changing. You could also look at the authors that are publishing open access or which journals they're publishing in. So all of that is possible. And we will continue to expand this table over time with use cases that people ask, but I'm going to go through a couple of those and just show you what that looks like. That last one I mentioned, which is the open access over time. This is a graph that I'm seeing more and more institutions doing, particularly in the library. So how has our open access practices changed over the last decade? So I chose as an institution, University of Arizona. You'll see that I used an open access filter. I did separate analyses, one with true and one with false. And then I limited to source type journals because I didn't want to worry about data sets and things like that at this point. And then I downloaded the data by summarizing by or grouping by publication year. And then I made this graph in Excel in about 30 seconds. And I can show that when we get to the Q&A. People are interested in the mechanics of going from the download to a graph, but very easy to get that information. Another common thing that I see universities doing is trying to understand how countries and institutions are changing over time in their contributions to a field. So this example I chose regenerative medicine, and you can see I use as a filter the concept regenerative medicine. Source type I limited to journal, mostly because I wanted to show you that these are things that you can do. You don't always need to, but there's different ways you can limit what sources you're looking at. Work type, I put not paratext. And this is another one where I intentionally chose this to let you know that you can say and not one certain thing. So you could say all the work types except journals. But here I've said and not paratext. If you're not familiar with paratext, long story short, when journals publish issues, they have lots of academic publications in them, and then they have things in between, like editorial notes, tables of contents. We consider that paratext. So sometimes it gets indexed, and you can just exclude it if you don't care about it. Year greater than 2000, and then countries, I was interested in Canada, US, UK, and China. Summarized by publication year, exported, and this is another one that I quickly graphed in Excel. And you can see here that US has been a leader in this field for a very long time, and China in the last 5 years has really ramped up their research outputs in this field and now have overtaken the US. So this is the type of thing that you're able to start doing. Sometimes you don't care about countries, you care about individual institutions and peers. So I chose 2 universities that are very close together, I think like 3 hours apart, have pretty similar research volumes. They're in the same province, so the University of Alberta and University of Calgary. And I said, limit to 2010 and beyond. And I will just point out, you can see here 2010 dash. If you put as your filter 2010 dash 2012, it's only going to include those 3 years. If you say 2010 dash and leave that open, it's going to do 2010 all the way up to present. So just a little trick I wanted to leave in there for you to know. And then I summarized by SDG, and you can see here on the sort of y-axis, we have all the sustainable development goals. And on the x-axis, we have the percent of that university's contributions to the SDG. And normalized by the number of outputs intentionally so that you could see how the contribution of the university sort of profile changes. And they're largely similar, these 2 universities, which we expected, but a couple differences. Life on Land, University of Alberta has disproportionately more publications on that and responsible consumption and production, whereas University of Calgary has disproportionately more good health and well-being outputs. So it's the type of thing you can do to start understanding how you compare to other institutions. Okay, next one is a very simple one close to my heart. I used as an example, let's say you want to find experts in a field, kelp forest, and you didn't find a concept or an SDG that really represented it. You can use search terms like I've done here. I searched kelp forest throughout all full text, limited to journals, just again to remind you that you can build that sort of complexity in, and said after 2013, because for this case, I really only want active researchers. And I didn't specify why I was doing this, but the example here is, let's say you're bringing all the researchers together in the world who study kelp forests, and you want to be able to find them to invite them to collaborate type of thing. This is how you would do that. And then I summarize by author, and you can see you've got the author name on the left, and then the total number of documents they have that match that search term. So this gives you a sense of who some of the productive people in that field are. But it also, you can export a list of hundreds of researchers to get the full list as well. Similarly, sometimes people aren't looking for individuals, they're looking for institutions. So this could be because you're a federal government wanting to give out money in a specific topic. This could be because you're a grad student looking to figure out where you want to do your postdoc in a particular field, or you're a research institution trying to figure out which institution to collaborate with on a goal that's really important to you. So the example I came up with here is which institutions in New Zealand are working on gender equality work in medicine. So I intentionally sort of made this a little more complex, but I started with the SDG that's gender equality, because that's one of the ones that exists. And I could have done good health and well-being, but good health and well-being as another SDG includes quite a bit more than I was interested in this particular use case. So I combined with top concepts. I looked through all the medicine concepts, and the ones that made the most sense for what I was particularly thinking about were medicine and family medicine. So I combined them with or and said, all the publications that have a concept medicine or family medicine and intersect with gender equality. And then I limited to New Zealand and said, these got to be New Zealand publications. And then I limited author count. And I want to take a moment to say this is really important when you're doing collaborative intelligence, because some fields, particularly medicine, can have hundreds and even thousands of co-authors on a publication. And if you include all of that, it doesn't always give you a good sense of where true collaborations are. And who might be leading in a field, because it can obscure that. You have the flexibility to change that to whatever you want in OpenAlex. So I chose author count 1 to 10. You could do 1 to 5, 1 to 50, sort of however you want to do that. And then I summarized by institution. And so University of Auckland, University of Otago, you can sort of see all the institutions that in New Zealand that are matching that query. Okay, the last example I want to give is one that people are doing a lot, and it's understanding collaborations. This could be between two countries. So I know the federal government often, when they're meeting with federal governments in other countries, want to understand what they're collaborating with in terms of research. This could be 2 researchers, it could be 10 researchers, it could be 2 institutions. It could be an institution with a country, but the idea here is that you have 2 entities and you want to understand what they're collaborating on. So I picked UCLA and UBC, 2 really large universities on the west coast of North America. And you'll see here, I used institution UCLA and UBC to make sure that every publication had co-authors from both. My work type, you'll see I limited to articles, just to remind you that this is the type of thing you could do, but you could also say and books, conference proceedings. You can sort of pick the ones you want there. And then author count, again, 1 to 10, which I do a lot for collaborative intelligence. And then instead of doing topics or SDGs, which we've done a bunch already in this presentation, I summarize by source. So you can get a sense of which journals these publications that are collaborative are published in. And you get a quick sense that there's quite a bit of work happening in chemistry, both chemical physics and biological chemistry. Nature, scientific reports, some really high-tier journals are happening from the collaboration of these 2 institutions. So that's all I wanted to say about the basics of how to start using the UI for research intelligence at the institutional level. But I did want to make a point to remind you that the UI is meant to be a starting point to help you start getting data, but all of the entirety of the data set is open through APIs and the means of downloading the whole data set. And so a lot more is possible. And sometimes the user interface will be a stepping stone, for instance, to building an internal dashboard. So this example over here on the left is a research intelligence dashboard showing the volume of open access over time in Canada. This is a great dashboard developed by Koki. The link is down there. I definitely recommend checking it out. But you can integrate our APIs with your internal and external dashboards to do things like this. So once you've come up with an analysis that you like in the user interface, you can sort of copy that API and work with someone who can code to develop something like this. So something to think about. The one in the middle is just a reminder that other programs exist to do bibliometric analyses, so you don't have to use Excel like I did in these examples. This is R, and there's a great package called OpenAlex R. It wasn't developed by us, but it's got great documentation online. And I rapidly produced this with very little coding skills to show all of the institutions in Australia, well, not all of them, but ranked by their top works kind of thing. The nice part about this in R is you don't have to download any data sets like you would with Web of Science or Scopus. You can just use the APIs and do any sort of analysis that you could imagine. And then the last one on the right is my favorite. I know lots of librarians and research professionals around the world are using VOS Viewer because it's free and does high quality analytics, and there's so much great documentation for it. If you're used to using VOS Viewer with Web of Science or Scopus, you're used to going online, downloading all the results, and then doing a bit of analysis in there. Because we have open APIs and you don't need a subscription, it's already integrated into VOS Viewer. So for this example on the right, I just found out what the University of Windsor's institutional ID was, put that into VOS Viewer, and it automatically talked to the APIs to produce this collaborative network of the institutions University of Windsor is working with. So lots of really cool, powerful things are happening with VOS Viewer and API potential. We do have a webinar coming up in December with the developer of VOS Viewer specifically on how you can use OpenAlex and VOS Viewer together. So stay tuned for that if you're interested. But all of this to say that this is an open database and it's going to be a bit of a shift to start thinking about it, but you can do basically whatever you can imagine doing with it. In the final moments, I have two sort of updates and calls to action. The first is on institutional data curation. As more and more people start interacting with this, you're going to be diving in, I hope, into things that you know well, looking at your author profile, looking at your affiliation profile, and seeing how it matches your expectations. If you've worked with Web of Science or Scopus before, you know that these algorithms are really powerful, the disambiguating algorithms, and ours is extremely powerful and does a really great job. There is the ability to increase the accuracy even more with some manual curation. So we are going to be developing in the near future text guides walking through how you could do that, how you can identify errors, and then once you've identified them, how you can submit those requests to us. But right now, we're looking for a few different libraries, or it doesn't have to be librarians. At some institutions, it's the Institutional Planning Office or the VP Research Office, but someone who understands the affiliation metadata work to collaborate with us. We want to work with you on your institution so that we better understand what sort of information is needed so that we can design this process for everyone around the world. So definitely reach out if you're interested in doing that. I see a bunch of folks that I've done this with some of the other databases, so hopefully you'll reach out and are interested. And then the last thing I want to say is, now that people are going to start using the user interface, and we really hope that you will, 30-minute recordings like this aren't going to be what people are looking for. They're going to be looking for quick hit tutorials is what we call them. When you have a very specific question, you want to see exactly how to do it. We're going to start developing those videos in probably second half of November. So not quite yet, but if there are things that you have in mind already that you'd like to see, let us know and we'll prioritize those. In the future, you'll be able to just submit questions and we can record videos for you that answer them. And if they're of broad use, we'll put them on the website so that anyone else who might have that will be able to answer it. And whether you're interested in the institutional data curation, or you have suggestions for the quick hit tutorials, or you've been playing around with OpenAlex and you have other questions, or you want to give any feedback at all, you can use this same link, openalex.org/feedback. It comes to us. It's the best way to get a hold of us. And we hope that you will reach out. But obviously it's open and you don't have to, which we also really appreciate. So that's the end of my presentation. I am going to stop here the recording. Thank you to everyone who is watching online afterwards, and thank you for everyone who's attending. And we have a couple people as panelists who will be able to help answer questions, but it looks like they've been doing a pretty good job keeping it going, and we just have a few left. So thanks again.